Hi everyone, it's Math with AUB. Second frame on vectors. We are about to discuss what do you mean by coplanar vectors or how to prove them, how to find scalar triple product or cross and dot in mix. Then there is a famous identity of dot and cross, and there is a formula for work done. When three vectors are coplanar, when three vectors are coplanar, their determinant ceases, their determinant is equal to 0. If the vectors are coplanar, their determinant ceases to 0. Take the coefficient 1, minus 1, 1, 1, minus 1 and 1. Second, 1, minus 2, minus 3, and the third one is 3 minus alpha 5. It is given to us if these three vectors are coplanar, find the value of alpha. Find the value of alpha. It is given to us if vectors are coplanar. Coplanar means their scalar triple product or determinant is equal to 0. Expand positive 1, delete first row, first column. The position of this entry is in first row, first column. It means delete first row and first column. What we have? We have negative 2, negative 3, negative alpha and 5. Minus belongs to formula. According to the position of subscript, it is first row, second column. First row, second column. First row, second column. 1 plus 2, 3. Addition of subscript is odd. We have to introduce minus. Minus same, minus there with the original quantity. Now delete first row, second column. 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 We have 1, minus 3, 3 and 5. First row, second column. Then position of this one is first row, third column. First row, third column. 1 plus 3, 4 means positive. Right one. Delete first row, third column. First row, third column. We have 1 minus 2, 3 minus alpha. It's equal to 0. Expand. First from right to left, it will become minus 10. This minus belongs to formula. Minus alpha and minus 3 alpha, it will result in positive 3 alpha. Positive 3 alpha. Minus minus plus 1. 1 5 the 5. Minus belongs to expansion formula. 3 into minus 3 is 9. Minus 9. Plus 1. Minus alpha. Minus belongs to formula. 3 into minus 2, that's our minus 6. Minus 6, sorry. Minus 6 is equal to 0. Now multiplication with 1, minus 10, minus 3 alpha, minus minus plus 1 times 5 plus 9 plus 1 times minus alpha plus 6 is equal to 0. Solve for alpha. Minus 10 minus 3 alpha, it will become 5 plus 9 14, 1 times the 14 14. 1 times negative alpha alpha, that's our plus 6. Minus alpha minus 3 alpha. Minus alpha minus 3 alpha, it is our minus 4 alpha. Minus 4 alpha. There is minus 10, positive 14 and positive 6 plus 20. Positive 14, positive 6 plus 20 minus 10. Here remains positive 10. Positive 10. Solve for alpha. Minus 4 alpha is equal to minus 10. Or alpha is equal to minus 10 over minus 4. Minus minus cancelled out. It will become 5 over 2. So the value of alpha is 5 over 2. If these three vectors are coplanar, then the value of alpha is 5 upon 2. 5 upon 2. When vectors are coplanar, their determinant is equal to 0, or that is the formula for finding a scalar triple product. Dot and cross mixed, it's equal to A1, A2, A3, means the ijk components of A as well as B as well as C. That is the way for finding a scalar triple product in a single frame. Scalar triple product. Move to question number 7. Next question, lump sum 74, day number 25. Second question of day number 25. Lump sum question number 74. Find the value of 2i cross 2j dot k. Look at this. If the flow of the vectors is according to alphabetical order, then the missing one is the answer. Missing one is the answer. If the flow of the direction is not alphabetical, then the result is the missing one, but with the negative sign. I cross J, positive K, or J cross I, negative K. If the flow remains same in alphabetical order, the answer is the missing one and the positive one. If the flow is opposite according to alphabetical order, the result is missing one and with negative sign. Negative sign. Look at this. 2I times 2J, 2 to the 4. I cross J. Flow is same. Answer is K dot K. We are familiar from the dot product. K square results in 1. So the answer of this quantity is 4. Answer of this quantity is 4. Or one can manage in that fashion. This kind of triple product fashion too. There's no I, there's no J, no K. 0, 0. There's only J. 0, 2, 0. There's only K. 0, 0, 1. According to the definition of determinant, except the man diagonal, all the elements are 0. There, its determinant is equal to the product of the leading diagonal elements, pivot elements. 2 times 2 times 1, it's 4. Either take this tip or this, it's up to you. Question number next, we have B 3J dot K cross I. No confusion here as well. For example, take determinant. There is only J, no I, no K. 0, 3, 0. Only K, 0, 0, 1. Only I, 1, 0, 0. If you expand this determinant, you are going to what? Only this category, this category. Negative 3, delete this row and this column. We have negative 3 times. That's a 0, 3, 0, 0, 0. There's 1, 1, 0, 0. How to expand that? Pass me the duster. It's okay. 0 times 0. What remains? 0, 1, 1, 0. Minus 3 expand 0 times 0, minus 1. So minus minus plus 3 is the answer in that case. Or flow wise 3J K dot I. Look at this. Don't get yourself confused. Look, first I, then J, then K. After I, again the loop starts from K, or after K, again the loop starts from J. So K into I results in positive J. And 3J square. J square according to dot product is 1. 3 times 1 is 3 times 1 is 3. 3 times 1 is 3. Moving to next one. K I G. Such things can also be written in that fashion. Same thing. Either if you want to apply determinant 0, 0, 1, I 1, 0, 0, J 0, 1, 0 and expand. Only remain this one, this row and this column. Delete what remains. Plus 1, 1, 0, 0, 1. So 1 minus 0, it's R1. It's R1 in that case. What about next? It's easy one. I, K. I, K. I, K. Write their coefficients. Determinant 1, 0, 0, 1, 0, 0, 0, 0, 1. As two rows are identical, the value of the determinant is going to be 0. The value of determinant is going to be 0 as two rows are identical in that case. Moving to another elegant question, a famous identity, a cumbersome to prove. If you are going to expand, if you are going to utilize some interchange properties in determinant, then it will be solved in blink of an eye. Flash. Let's see and find out what is this. U dot V cross W plus now V dot W cross U plus W dot U cross V is equal to 3 times u dot v cross w. Easy to prove. Look at this one. It is in the same fashion u v w. It's good. Make this one as u v w to get this 3 times u v w. Take this one v v1 v2 v3 w1 w2 w3 u1 u2 u3. We have to fix in that direction u v w according to alphabetical order. Interchange r1 with r3. Interchange r1 with r3. We need u1 u2 in first interchange. Whenever we interchange in determinant, we have to change the symbol of determinant overall. It will become u1 u2 u3 w1 w2 w3 same and v1 v2 v3. Okay, after u we need v. Now interchange r2 with r3. Another interchange, another minus. Negative times negative, we have u1 u2 u3 v1 v2 v3 w1 w2 w3. Minus minus plus, it is same as uvw plus u1 u2 u3 v1 v2 v3 w1 w2 w3. So it's equal to u dot v cross w. We have make this same. What about this? This can also be switched over to uvw in the same fashion. Let's see and find out how. W dot u cross v. Expansion according to determinant first is w1 w2 w3 u1 u2 u3 v1 v2 v3. We need u1 u2 u3 in first row. Interchange r1 and r2. Introduce minus. We have u1 u2 u3 w1 w2 w3 v1 v2 v3 r3 remains same. We need after u v. Now interchange r2 with r3 in the same token. Interchange another minus to be introduced outside the determinant or change the overall symbol of the determinant. We have u1 u2 u3 v1 v2 v3 w1 w2 w3. It turns to be positive and it's equal to u dot v cross w. So this is equal to u dot v cross w as it is. We haven't solved. We have converted this one to u dot v cross w as well as this one u dot v cross w. How many times? One time, and 3 times. Means 3 times u dot v cross w. It is the required identity that we have proved utilizing tiny property of determinants. Tiny property of determinants. Moving to final question of today. An elegant question, a little bit typical one for work done. Work done is given by the dot product of force and displacement. Work done is given by the dot product of force and displacement. We have given force very explicitly, and it is also mentioned that force is applied in the given vector and with a given magnitude and displaces the particle from one point to another point. Let's see and find out how to get F according to the given condition and how to make displacement from the two given points. Two given points. Yes, a force of magnitude 6 units acting parallel to this. We have given a vector. Our force is acting along the direction of this vector. Force acting in that direction, but having magnitude 6, it is a vector not having magnitude 1. First make this one a magnitude unit vector. First make this a unit vector. Unit vector means magnitude 1. Then multiply this one with 6. So it is going to be our required force in the direction of 2i minus 2j plus k with the magnitude 6. Let's see and find out. First make this one unit vector. 2i minus 2j plus k dividing its determinant, magnitude 2 square minus 2 square plus 1 square. 2 minus 2j plus k over square of 2 is 4, negative is 2 square 4, 1. 4 plus 4 plus 1, 9. 9 means through, 9 means 3, divide by 3. It's equal to 9, 9 means 3. Now it's a unit vector, it's our unit vector in the direction of 2i minus 2j plus k. Make this vector having magnitude 6, multiply this unit vector with 6. 6 times 2i minus 2j plus k divided by 3. 2 multiply 2 throughout. So our force is going to be force in the direction of 2i minus 2j plus k having magnitude 6 is to be 2 to the 4i 4j plus 2k. One can easily verify by finding its magnitude. The square of 4 is 16. The square of negative 4 is 16. The square of 2 is 4. 16 plus 16 plus 4, 36. Magnitude of 36 is 6. So it is a force in the direction of 2i minus 2jk having magnitude 6. That's our force. And it displaces the particle from 1, 2, 3 to 5, 3, 7. How to convert the point into a vector? Always keep in mind final minus initial. So our displacement is 5 minus 1, 3 minus 2, 7 minus 3. It will become 4i plus 1j plus 4k. Sorry, it's our 1j plus 4k. That's our force. That's our force, and that's our displacement vector. Displacement. Now work done is given by dot product of force and displacement. Our force is 4i minus 4j plus 2k dot product with 4i displacement 4i plus j plus 4k. 4 for the 16 I square 4 minus 4j into j 4j square 2 for the 8k 2 for the 8k 8k square. According to the property of value of I square j square k square in dot product, they result in 1 16 minus 4 plus 8. So minus 4 plus 8 4 16 plus 4 20 joules. 20 joules is the answer in that case. It's my tiny effort in the second frame on vectors. What is coming for you is how to prove the vectors are parallel, perpendicular, how to find a constant when vectors are parallel or perpendicular, find the projection of A on B or B on A, projection of one vector on another vector. These 2 to 3 things are remaining, as well as movement of the force, movement of the force, moment, movement of the force. They are coming in next frame, third one. It's all by itself. Next.